Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Ahmad SYAHMI bin Amir ZAKI. My student ID is 2020859756 and my supervisor is Prof.MADYA.DR AZLINA binti BAKAR. So today I will be presenting about my FYP proposal, which my topic is mechanical properties of epoxy resin and rice husk. So for content, that includes project summary, introduction, literature review, problem statement, objective, scope and limitation of the project, methodology, expected result, references, and Gantt chart. So for project summary, rice husk is a natural additive that is frequently used as a stabilizer for a variety of masonry materials due to its pozzolanic property. Rice husk can be used either its raw or ash form. The objective of this research is to investigate the mechanical properties between epoxy resin and rice husk and to fabricate the composite samples. 5, 10, 15, and 20 weight percentage of filler loadings will be fabricated. The flexural and impact test will be tested as part of mechanical analysis. And this experiment will be conducted under room temperature. So, firstly, for the introduction for epoxy resin, the development of novel engineered material for the building, packaging, furniture, and automotive industries that use modified thermoset polymer is being sparked by scientific research due to environmental concerns. Epoxy resin, to put it simply, is employed in any product that calls for a powerful adhesive. Epoxy resins are used in coatings, electronic materials, adhesives, and fiber reinforced composite matrices due to their excellent mechanical properties, strong adhesion, superior heat resistance, and high electrical resistance. For rice husk, in many nations that produce rice husk is one of the most accessible agriculture waste. Around 600 million tons of paddy rice are produced annually worldwide. Rice husk is a type of organic waste that is abundant. It is a significant byproduct of rice milling and agro-based biomass industry. As a result, the use of rice husk in residential and industrial processing not only help to boost farm income directly and indirectly, but it also provides an alternate solution to the rice husk disposal problem. Next is literature review. Application of epoxy resin. Epoxy resins are thermoset polymer that prior to curing have one or more active epoxide or oxidant groups at the ends of the molecule and a few repeated units in the middle. They are used in a variety of applications, including coatings, adhesives, and composites. Epoxy resins have several important applications such as adhesive for general purposes, binder in cement and mortar, making rigid foams, non-skid coating, solidifying sandy surfaces in oil drilling, industrial painting and coatings, potting and encapsulating media, and also fiber reinforced plastic. Epoxy resin offer a few benefits that are not shared by other traditional thermoplastic or thermoset resins. Epoxy resin consumption has increased almost annually since the 1940s when the Devo Reynolds company began mass production. Type of hardener. Because of their favorable thermal and mechanical properties, amine hardener are frequently utilized in the production of structural adhesive. There are three distinct amine compounds that can be synthesized from ammonia. They are distinguished by the number of hydrogen molecules of ammonia that have been substituted for hydrocarbon. A variety of amine exists in nature, including primary, secondary, and tertiary amines. Epoxy resin relies heavily on amines, which are categorized as either aliphatic, alicylic, or aromatic depending on the type of hydrocarbon they react with. Rice husk and its application. Rice has high ash and silica content among other distinctive physical and chemical characteristics, make it ideally suited for both domestic and industrial application. As you can see, figure 1 lists the most important parts of rice husk and its physical properties. Rice husk is a fibrous material made from cellulose that comes in a wide range of aspect ratios. It is possible to use rice husk as an insulator in the synthesis of organic compound and in other contexts. So for the problem statement, as an engineer, they must come up with a new material that are cheap, have high mechanical qualities, and relatively light in weight. There has been rise in interest in the field of composite due to the increasing demand for eco-friendly material, the increasing depletion rate, and the rising prices of petroleum-based plastic, as well as the pressing requirement of environmental regulations. Polymer composite made from low-density particulate materials like rice husk offer a viable solution to this problem. Next, polymer composite often combine an epoxy resin matrix with one or more filler. So for the experiment, the mechanical properties of the epoxy resin ought to be studied to determine its flagellal strength as well as its impact strength. So objective first is to fabricate the composite samples, and second, to investigate the mechanical properties of the composites. Scope and limitation of the project. Scope of the project. Epoxy resin is employed as a metric material to investigate its mechanical properties in this research. As a filler for evaluating the qualities, rice husk has been chosen. The samples were fabricated using 5, 10, 15, and 20% by weight of the mixture. The procedure will be performed under room temperature. Flexural and impact testing will be performed on the samples. So the limitation of the project, due to space and machine limitation, students must wait in line to use the lab equipment. And students must make their own plate mold because the plate mold in the Uitm lab is broken. So as you can see on the right side is my flowchart of the methodology. The experiment was conducted according to the predetermined flowchart. This was done to guarantee that the research ran smoothly. So as you can see, from start we go to phase 1, which includes wash and dry the rice husk, blend the rice husk using blender, insert the rice husk into monomill, sieve the rice husk to below 250 microns, and then next is phase 2, which is we fabricate the samples, which we start fabricate using the mold, and phase 3 we try to test for flexural strength and for impact strength. And if the results does not converge, then we need to repeat to phase 2. So as for the expected result, according to the findings of the research, for flexural test, the flexural strength will decrease in proportion to the amount of rice husk filler added. This is because the weak interflexure region between the rice husk has increased. And it has also been shown that there is reduction in flexural strength when the filler content is increased. As you can see in the graph for flexural strength as composition, the flexural strength is gradually decreased when the composition and increase, and it is the same for the flexural strength vs composition. For the impact test, as you can see in the graph on the right side, it displays a gradual drop in impact strength with increase in filler content for rice husk composite. This may be seen as a correlation between the two variables. A fracture that is caused by an impact will spread toward a place that has poor interfracture when it begins to spread. The impact strength tends to gradually decrease as the filler content increases. On the other side, filler restrict the mobility of metric molecules if the filler metric addition is very high. And this might happen when fillers are used in a matrix. As a direct consequence of this, the impact strength is diminished as well. So this is my reference. I have 15 reference that I got from journal. And this is my Gantt chart. The title selection, the FYP, the title selection until proposal draft preparation was I prepared and done. And the other, I will be focused for FYP2. So I think that's all from me. Thank you.